Are you brave enough to descend into the ultimate unknown? Forget Everest, forget space, forget Mars. The real adventure lies beneath your feet. Thousands of miles down, unreachable by any human hand, rests a world we've never seen. A world that pulses, burns, shifts, and protects everything we know. This video isn't just about a journey. It's about confronting the terrifying truth of what lies at the heart of our planet. From forgotten expeditions to the edge of madness, to the crushing heat and darkness just beneath the world we walk on. What would it take to reach the Earth's core, and what might be waiting for us there? This is the Forgotten File, and today we open a case humanity isn't prepared to close. Part 1. The Allure of the Abyss. The Earth is 7,917 miles wide, a sphere of iron, rock, magma, and mystery. But despite our satellites reaching the edge of the solar system, our deepest descent into the Earth's crust, just over 7.6 miles. That's it. A thin scratch on the surface of a shell that goes down 4,000 miles. To this day, we've explored less of the Earth below us than the Moon. And yet, the Earth's interior isn't empty. We know that. It holds the magnetic field that shields us from solar radiation. It generates earthquakes, fuels volcanoes. It recycles the crust through tectonic movement. Everything we see on the surface is shaped, quietly, by what lies beneath it. And what lies at the very center, something we've only dared to imagine. Why are we so drawn to the core? There's a gravitational pull, not just physically but emotionally, toward the center. Mythology from around the world has placed the underworld, the spiritual realm, or the unknown, beneath us. For the Greeks, it was Hades. For early Buddhists, it was Naraka. For certain indigenous traditions, the earth itself was layered, each level deeper, stranger, more sacred than the last. Even today, we speak of things being close to the bone, foundational or deeply buried. The core represents power, but also danger. And that tension has given rise to centuries of wonder and fear. Because the deeper we go, the more reality bends. That molten realm below us isn't just made of metal and pressure. It's become a symbol of something else, something impossible. What's actually down there that we know of? Let's pause and ground this in reality. Earth is made of 4 main layers. 1, the crust, what we live on. 2, the mantle, dense, semi-solid rock. 3, the outer core, hot, liquid metal. 4, the inner core, a sphere of solid iron and nickel the size of Pluto. The crust varies in depth from 5 to 43 miles. Then the mantle drops another 1,800 miles. Then comes the outer core, liquid metal, spinning. And finally the inner core, solid, superheated under extreme pressure. The temperature there is estimated at more than 9,000 degrees, hotter than the surface of the sun. And the pressure, more than 3.5 million times atmospheric pressure. We can't drill through it. We can't send machines to survive it. We're blind to the center of our own world, and maybe that's why it fascinates us so much. A fear we can't touch. For centuries, we faced outward for the mysteries, into the stars, distant galaxies, other planets. Yet what scares us more may not be out there. It may be right beneath us, seething and unreachable. Because if you picture it, really picture it, a journey to the core is a voyage into permanent night, deeper than any trench, under layers of unknown rock, heat, and pressure. It's not just deadly, it's alien. That truth, the inaccessibility of the Earth's full depths, opens the door to all kinds of speculation, which is exactly what people started doing. History's obsession with the underground writers, scientists, and storytellers have always imagined what lies below. In 1864, Jules Verne published Journey to the Center of the Earth, a tale of explorers who descend through a dormant volcano and discover a massive subterranean world, complete with forests, oceans, and prehistoric life. It was fantasy, yes, but rooted in scientific possibility and Charles Darwin's recent theory of evolution. It didn't take long for others to create maps of hollow Earths, inner civilizations, even central suns that existed at the planet's heart. It was never proven, but the idea refuses to die. Even in modern conspiracy theories, people speak of deep cities, hidden species, or lost races living under us. Where does that come from? The answer might surprise you. Science didn't disagree at first, we just didn't know. Seismology only developed in the early 1900s. Before that, it really was anyone's guess what lay underfoot. Which means, right up through the last century, the Earth's interior remained a canvas of myth and theory, just waiting to be drawn on. The core as a symbol. The core, whether literal or imagined, represents something greater, not discovery, but persistence. Because to even try to reach it is to accept one thing, that you will likely never come back. And maybe that's the point. We've mapped the heavens, walked on the moon, stared beyond the stars, but beneath our own planet, we're still guessing, and every guess unlocks a bigger fear. Coming up in part 2. Next time, we explore how fiction blurred into scientific obsession. From literary classics to hollow earth cults, from imagined creatures crawling under the crust to real science warning us why it may never be reachable. What happens when curiosity turns into madness? And what terrifying theories still linger among the whispers of Earth's impossible depths? Find out, only on The Forgotten File. For as long as we've looked up at the stars, humanity has also wondered, what lies beneath? In part 1, we explored how the Earth's depths have fascinated, terrified, and resisted us. We scratched the surface, literally, of what little we know about the planet we stand on. But now, we descend further. Because beneath every scientific map is a myth, and behind every research paper, a shadow of the unknown still lingers. In this chapter of The Forgotten File, we explore the fictional journeys and the real horrors that have defined our obsession with reaching the Earth's core. This is part 2, Fictional Journeys, Real Terrors. A journey only imagined, Jules Verne's descent. In 1864, science fiction author Jules Verne published one of the most enduring adventure novels ever written. Journey to the Center of the Earth. It begins with a cryptic note. A volcanic crater in Iceland, an eccentric professor, and a descent into a hidden underground world, complete with oceans, prehistoric beasts, and lost civilizations. At the time, it was fantastical. No evidence, no feasibility, and yet, readers were captivated. Because Verne didn't just write about going underground, he wrote about discovery beyond comprehension. It was terrifying, beautiful, and inspiring, and even those who knew it couldn't be true began to wonder. But what if it was? Fantasy meets force. What it would take, let's pause the fiction and appraise the facts. If you were to begin a real descent to the Earth's core, you wouldn't get far. You'd pass through the crust in the first few miles, then hit the mantle, a section of hot, dense rock nearly 2,000 miles thick. The deeper you go, the temperature rises, eventually topping 9,000 degrees Celsius at the core. The pressure crushes more than 3 million times what we experience at sea level. The rock becomes unstable, something between solid and liquid. And even if you could somehow survive that, there's the problem of time. At our current best drilling speed, it would take tens of thousands of years just to go a fraction of the way down. So no, Verne's tale remains fiction, but the impact it had, that's very real. When fiction inspires real fear after Verne, others followed. H.G. Wells's The Time Machine hinted at underground species, devolved remnants of humanity. In later pulp fiction, writers described massive voids beneath the Earth, home to monsters, advanced civilizations, and upside-down continents lit by subterranean suns. It was all fiction, but it felt like possibility, especially in the early 20th century, when science was racing to catch up with imagination. But the darker side came quickly, because if there's a down, there must be a beyond, and that's where the terrifying theories emerge. The hollow earth theory, a dangerous obsession. In the 17th and 18th centuries, before we had modern geology, there were very real scientists, including Edmund Halley of Halley's Comet fame, who proposed that the Earth was hollow. The idea, a sphere within a sphere, or multiple layers of shell with inner worlds. Some models included central suns. Others suggested entrances at the poles. A few claimed advanced underground civilizations lived peacefully below, cut off from us for millennia. It started as speculation, it mutated into myth, and eventually into cult belief. By the early 1900s, Hollow Earth theory had merged with spiritualism, mysticism, and even early science fiction cultures. One theory claimed that Nazis had sought a way into the Hollow Earth through Antarctica. Another claimed that UFOs weren't from space, but from deep beneath the planet's surface. Some still believe it today. But here's what makes it unnerving. Even if the Earth isn't T-hollow, the idea fills a vacuum, because the deeper we try to go, the less we know. And people invent what evidence hasn't confirmed. The very real forces below. Let's get back to facts, because they're terrifying enough. If you tried to send a probe to the core, here's what it would face. Over 6,000 degrees of temperature. Crushing pressure that would instantly implode any known material, endless tectonic activity, plates shifting, seismic compression, layers of unknown minerals, under conditions we cannot replicate. Some scientists believe we may one day use deep-sea trench plate subduction zones to hitch sensors downward over millions of years, but practically speaking, we may never get there. And this is what prompted some to imagine instead, not what's really down there, but what goes horribly wrong when we try to reach it. Fiction floods in, born from real danger. Since the 1950s, Hollywood and authors have looked below the surface, not with wonder but fear. Movies like The Core imagined a dying magnetic field, requiring a high-tech vessel to travel down and jumpstart the Earth with nuclear explosions. Others imagined monsters beneath the crust. Films like Tremors and At the Earth's Core portrayed ancient life still surviving in deep caverns. And horror fiction often sets its climax not in space, but deep within the Earth. There's good reason. Space is empty, cold, beautiful. But the Earth is hot, closed in, loud, molten, dangerous. Descending into it is a journey without escape, which makes it way scarier. Science still has no answers. Despite decades of research, here's what we still don't know. Exactly what the core is made of, whether it spins faster or differently than the crust, how stable it really is, and whether changes in the core could one day destabilize the magnetic field. If materials deep below could reveal new forms of matter, every simulation is still based on indirect data, seismic waves, gravitational shifts, magnetic field readings. We have models but not measurements. We're guessing again, just like Werner did. And maybe that's why descending into fiction still feels right. Coming up in part 3, what happens when humans stop imagining journeys to the center and actually try? From Cold War drilling experiments to buried tech with nowhere to go, next time we explore the real attempts that scratched the crust and fell apart trying. Don't miss historical scratches and deep dreams, only on The Forgotten File. We've imagined the journey. In fiction, explorers ride golden elevators through the mantle. They battle magma rivers, slip through crystal chambers, or find long-lost civilizations glowing in the dark. But fiction doesn't forge tungsten drill bits. Fiction doesn't buckle under 1 billion tons of pressure. In this chapter of The Forgotten File, we abandon imagination for something more sobering. The real story, of real men with real machines who tried to dig deep, and how the Earth reminded them they were not welcome. This is part 3, historical scratches and deep dreams. The surface is a lie. Right now, you're standing on a wafer. If Earth were an onion, the crust is the peeling on the skin, and yet all of human history, all of it, has unfolded only on that top layer. We've climbed Everest. We've mapped the seafloor. We've drilled for oil, gas, and resources, and the single deepest hole we've ever dug, just 7.6 miles. That's the Kola Super Deep Borehole. The deepest hole we've ever made. In 1970, the Soviet Union began an engineering project in the Arctic region, the Kola Peninsula. Unlike anything the world had ever seen, it wasn't for oil, it wasn't for weapons. This time the goal was knowledge. The first few kilometers went smoothly. By the early 1980s, Soviet scientists passed the American record. By 1989, they reached an incredible depth, 12,262 meters, about 7.6 miles. But then they hit something else. Not treasure, not molten iron, but a place the Earth didn't want to give up. Temperatures deep below were much higher than expected, approaching 180 degrees C, 306 degrees Celsius. Drills broke, materials warped, sensors melted. What happens when you force yourself into places not ready? The planet pushes back. Kola was eventually sealed, not because we ran out of budget, but because we ran out of belief. And they weren't the only ones who tried. During the Cold War, the United States mounted its own ambitious effort. It was called Project Mohole, a plan in the 1960s to drill through the seafloor and reach the boundary between crust and mantle. The location, off the coast of Mexico. The budget ballooned, management fractured. By 1966, Congress pulled funding after spending millions, and still no result. The deepest they got? Less than 200 meters. Mohole failed, but the dream didn't go away. Why it's so incredibly hard to go deeper into Earth is not like going up into space. Space gives you vacuum, cold, risk. But the Earth gives you something worse: weight, friction, heat, pressure, time. The deeper you go, the harder the rock gets. Instruments overheat. Gas pockets collapse. Metal becomes elastic, then fails. Costs rise exponentially per meter. Even with today's ultra-hard technology, diamond bits, robotic drills, we'd be decades from moving beyond the upper mantle. And centuries, maybe, before we get near the core. And yet, we learned things. Even though we failed, we found fragments. As at Kola, tiny microscopic fossils dating over 2 billion years were uncovered miles below ground. New information about seismic layering and mineral evolution emerged. We discovered that water, trapped in rock under intense pressure, moves and mutates the geology of deeper layers. Each inch told a story no book had ever written. The deeper we drilled, the louder the Earth whispered, "I am still making myself." Are we still trying? Yes, but differently. Modern drilling focuses on energy, not depth. Geothermal taps into superheated rock to create long-term, clean power. But deep Earth exploration, the kind meant for pure science, is still rare. China and Iceland continue to explore towards super-deep boreholes. Japan's Chikyu-Haken project tries to reach deep ocean crust. The US still revisits ultra-deep drilling conversations, but cost usually wins. We're still scratching, just at different angles. Could we ever reach the core? If technology advanced, hypothetically, we'd need heat-resistant materials, stronger than anything we've ever produced. Energy sources that don't melt themselves before powering anything. Transport that doesn't collapse under 3.5 million atmospheres of pressure. And then there's the question of what would happen if we made it. Drilling a shaft all the way down could destabilize tectonic plates. It could create pressure leaks, trigger unknown seismic waves, even touch the unexplored outer core where magnetic fields are born. Do we really want to test that? Maybe the reason we only scratch the Earth is because we're being warned. An impossible dream or an inevitable one. Humanity always breaks its limits. We fly, we land on moons, we split atoms. So maybe 5 centuries from now, someone finds a way. Automated tunneling systems, self-repairing robot swarms, nanodrills moving centimeter by centimeter, chewing into the mantle across generations. Or maybe, from deep space communications, comes a message: you didn't dig far enough. Coming up in part 4. Now that we've met the engineers and the explorers, it's time to meet the core itself. What is it? What is it actually doing? And what role does the core play in protecting, and someday possibly ending, life on Earth? The answers may not be comforting. Next on The Forgotten File, the core's unyielding mysteries. We've tried to reach the core, we've drilled, modeled, theorized, but it remains untouched, unseen, unreachable. And while we've failed to get close, we've managed to collect just enough data to make it even more terrifying. In this chapter of The Forgotten File, we go to the center of it all, not through tunnels or fiction, but through the fragile lens of seismic echoes, magnetic fields, and theory. This is part 4, the core's unyielding mysteries. Let us start with what we know. The Earth's interior is layered like a brutal puzzle. Crust, the skin, we live here. Upper mantle, slowly churning rock. Lower mantle, dense and hot. Outer core, liquid iron and nickel swirling. Inner core, 6,000 XE, solid metal under pressure we can barely calculate. The inner core is like a tiny planet of its own, around 1,500 miles wide, about the size of our moon. But how do we know that? No one's been there. No probe has touched it. No radar bounces that deep. So where does this confidence come from? One word: seismology. The Earth speaks in shaking. Whenever an earthquake tears through the planet, it sends waves deep underground, rippling outward like sound in water. These waves move differently in solid versus liquid. Some reflect, others bend. Some never arrive at all. By watching where seismic waves show up and where they drop out, scientists have built a kind of X-ray of Earth's interior. It's only a model, but it tells a story. And that story says there is a spinning liquid outer core. Inside that, a solid metal center. And this system works like a giant dynamo, a cosmic engine. Its movement, rotation, and heat generate our planet's magnetic field. The core keeps you alive. Without that magnetic field, solar wind from the sun would strip Earth's atmosphere. Radiation levels would spike, skin would burn, satellites would fry, planes could no longer fly at altitude. The magnetic field is our invisible shield, and it comes from deep and violent motion in the outer core. Think massive, spinning rivers of liquid iron churning eternally at thousands of degrees. Without it, Earth might look like Mars. 50 million years of atmosphere, gone. One question though, what happens when the core stops? A magnetic reversal is already happening. Our magnetic field isn't permanent, it wobbles, shrinks, flips. Roughly every 300,000 to 500,000 years, the North and South poles switch places. That's called a geomagnetic reversal. And it's not just theoretical. It's happened hundreds of times in Earth's history. Scientists believe we're in the early stages of another right now. The North Magnetic Pole has been drifting rapidly towards Siberia. We don't know when the flip will happen. Could be next century, could be sooner. The last time this occurred was around 780,000 years ago. We weren't exactly recording history then, but next time it could devastate communications, navigation, power grids, birds, bees, animals that rely on magnetic direction. Your phone's compass might get confused, so might everything else. The inner core's movement. Still a mystery. In 2023, researchers released evidence suggesting the inner core may rotate independently from the rest of Earth. and that it might be slowing down or even reversing its direction of rotation. What does that mean? Honestly, we don't know yet. Some theorize this could affect magnetic field strength, tectonic behavior, even day length over millennia. Others say it's just part of a natural wobble system, a planetary heartbeat too slow to see. But when the heart is the size of a moon and 6,000 degrees, we should listen. Is there life deep below? This is where mystery meets biology. You might think life exists only on the crust, but scientists have discovered entire ecosystems inside the Earth's crust. Miles down, they're called extremophils, organisms living in extreme heat, toxic chemicals, zero light. Some have been found in rock over 2 kilometers deep, surviving on water and minerals trapped in formations for millions of years. This creates a haunting scientific twist. If life exists deep below our surface, maybe it once existed in the crust of planets like Mars. Life hidden beneath, not above. Life that never sees the sky, but keeps moving unseen, far from sunlight, completely alien, even to us. So what else could be waiting? If Earth's core can rotate independently, if magnetic shifts can reverse the field, if life can live without oxygen, light, or surface ecosystem, what else is hiding in the layer we still can't reach? A massive cache of rare Earth minerals, unknown materials from our planet's birth, remnants of the primordial stirrings of the solar system, a dynamo that, if disturbed, could shut the shield off permanently, or something stranger, like pressure-created matter we've never seen. Here's the eerie part. We don't know if reaching the core would kill us or save us, because for every terrifying answer down there, there might be a solution too. A new energy source, a stabilizing core map, the key to understanding planetary formation across our galaxy. But to get it, someone would have to go first and not come back. Coming up in part 5, now that we've explored the science and the danger, we end with a question historians, scientists, and storytellers have all asked: what if someone really goes? In part 5, we imagine the future. A hypothetical expedition, real tech, real humans, real sacrifice. What would such a mission require? What could it awaken, and should we try? Only on the Forgotten File. So far we've drilled a little over 7 miles into the Earth. The inner core still lies more than 4,000 miles down. No tunnel, no technology, no lifeline. And yet the question remains, what if we tried? In this final chapter of the Forgotten File, we explore a speculative yet scientifically grounded scenario. Could humanity ever launch a real expedition to the center of the Earth? And if we did, what would it take to survive or return? This is part 5, the ultimate expedition, a future echo. What it would take just to begin to reach the core. We would need machines that today's engineers still dream about, because we're not just digging, we're fighting. Temperatures of 9,000, 10,000 degrees, pressures over 3 million times atmospheric norm, layers of molten metal and volatile rock, shifts in geology we barely understand. So what would we need? 1. Ultra-resistant materials. All current drilling tools fail beyond a few hundred degrees. To survive the journey, we'd need metamaterials, heat-insulated, flexible under crushing weight, and practically indestructible. 2. Self-healing nanobots or AI-driven tunnelers. Conventional drilling doesn't survive deformation at those depths, but autonomous machines capable of adapting to underground ecosystems in real time might. 3. Energy that powers itself. We can't run a cable 4,000 miles long, so the system would need to generate power internally, maybe from geothermal or nuclear microreactors. 4. Time. This wouldn't be a 6-month mission. It could take centuries, or require generation-based commitment, like building cathedrals, not for ourselves, but for those who come after. How might it work? A hypothetical path. Let's imagine a plan, year 2075. Global climate crisis has deepened. Fossil fuels are regulated. Energy independence is the new space race. Nations invest in core deep geothermal tech. One project in Iceland, or under the Pacific, begins building a bore chain system, a series of connected vertical shafts descending deeper than ever before, lined with data sensors, sealing each segment behind it. AI monitors core data in real time. Pressure map tunneling adapts constantly. Radiation levels surge inside certain corridors. Temperatures become blinding. And yet, progress inches forward. By 2120, humanity reaches the outer core, not physically, but via probes, sensors, maybe robots that can squeeze through gaps in rock we don't even have names for yet. The human factor, which raises the harder question, should people go? Could a single person make it, or should they? Physiology is the limit. No material suit, no exoskeleton, no shield would be enough, not in conventional terms. So perhaps the first explorers would be enhanced humans, not sci-fi superheroes, but individuals in AI-integrated capsules, fed by nutrients, tissue monitored in real time, physically reshaped for the descent. Conscious, but supported by machine learning and hormonal control. They wouldn't walk or run. They'd be encased and dropped, drifting downward mile by mile, a sleep journey, a deep dive. And when they reach the unseeable, do they open their eyes or never wake up at all? The risks we can't model. Let's say we do it. Let's say we build the tech, design the transports, train the crew. Would we be prepared for what happens if we're wrong? We pierce a pressure seam never meant to be opened, collapse magnetic equilibrium, accidentally trigger deep seismic instability, even unleash gases or internal processes long kept. Hidden, our intent could be scientific, our outcome irreversible. In searching for truth, we might click Run Simulation on a planet that already built its own firewall. And just like Kohler, that firewall might melt the drill, or worse, say nothing, no bang, no twist, no explosion, just silence, and a planet waiting. What could we learn? Not every part of this is fire and fear, because beneath the crushing depth could lie answers we've chased for centuries. Answers like why earthquakes follow shadow rings, why the magnetic pole has started drifting 10x faster in recent decades, whether Earth's core once spun faster than gravity itself predicted, whether our planet is cooling, and how that would impact all future life. There could be signatures of the planet's birth frozen in iron swirls, isotopes the age of the solar system, density patterns that reveal if Earth was ever struck by another planetary body, or signs that life began underneath, not above. Microbial remnants fossilized in rock beyond light. The first spark of biology, flickering in water locked in mineral pockets, far beneath anything we've ever reached. It's not just about reaching the center, it's about rewriting the top. The final ethical question. But if we could go full descent, should we? Do we have the right to puncture a system that protects all life, to gamble on knowledge, at the cost of stability? Some mysteries are meant to be understood, some should be watched, not touched. Maybe the Earth doesn't want us there not out of malice, but because we're not ready. We treat the crust with confidence, but the core, that's sacred, or at least it's still silent. Final reflection. We've imagined cities in the stars, colonies on Mars, escape plans from our own planet. But what if the last great journey is not upward? What if the next frontier is down? The Earth holds everything we've ever loved and everything that came before us. We've stood on its crust for millennia, but we've never met its heart. Maybe one day someone will descend, maybe they'll touch the core, and maybe the planet will finally speak. What will it say? We've been waiting. So have you. This is the forgotten file. And now, you know just how close we are to reaching what lies beneath.